functions than you do. Did you all actually do it? I don't think it's actually knowing.
It is not the same as log.
No? Okay. It looks like
It looks like it, but it's not.
It's like I see on my calculator. How much notes
Yeah, sometimes I
right here. I'm like, what is log?
Well, mine is a little bit up here, and then this back, and then that front, and then that back.
But I write small.
But I also have lots of examples. We won't necessarily do all of the examples. Okay. So yesterday we did operations where we put different functions together, either with addition, subtraction, multiplication, or division, right? Today we're going to be putting functions inside of functions. That is what composition means. So I'm not going to give you the super duper crazy definition because it doesn't really make sense to me. Well, it makes sense, but it doesn't make sense at the same time. So essentially what it means is if I'm taking f of g, which is what the fog here stands for, this is the same as taking my inside function g and plugging it in to my outside function f. And then solving. So the inside gets plugged into the outside. In the notes, if you've already looked at it, there's a nice little kind of like table example. We're not going to do that one in class because it's not on your homework. So I will table that one for a different time when we actually examine function tables and what they mean. I'm going to jump right ahead if you're looking at the notes to example B. And that's what we're going to start with. So for this example, let's assume that I have an f function and a g function. My f function is 2x minus 5, and my g function is 4x. For this composition, I would like to do f of g of x. So whenever we have a composition written out like this one, I always suggest that we go ahead and write it in the alternate notation as well, which is f parentheses g parentheses x, and then close them both. By doing this, we're able to kind of see what is an inside function and what is an outside function based off of the parentheses that I have present. So here, I see that g of x is my inside function, which means I'm going to take g and plug it into f. What this means for our functions is that I'm going to take the entirety of 4x and plug it into f wherever there's an x present. So I'm substituting the 4x in place of the x in f. So my composition f of g of x becomes 2 times 4x minus 5. So I literally replaced the x in f with the function 4x from g. And then I would just simplify this down because I'm not plugging any number into it. So I would multiply the 2 and the 4, and I would get 8x minus 5. That would be your simplified answer for this one, yes.
Is that how you want it?
Yes.
You never say that.
Okay, how do we feel about this? Yes.
Why would we not like solve for x and like 5/8? Like why would we?
Because I'm not technically setting this equal to 0. I'm just saying that my composition is that.
Oh, okay.
if you wanted to write it out with that on there as well.
Is that it first?
What?
Then it won't be that bad.
So now let's go the other direction. Instead of taking G and plugging it into F, I'm going to take F and plug it into G. So notation-wise, I'm going to do G of F of X. So now F is my inside function and G is my outside function. I always like to underline my inside function and draw an arrow going to my outside function. That way we remember the order in which it's being plugged in. So this means that every variable in my G function will be replaced with the entirety of my F function. So then this will become 4 times the entire F function, 2x minus 5. Just like before, I would go ahead and simplify this out. And it will become 8x minus 20. Questions, concerns, or issues with that? Just like before, we can identify our domain from this because they're simply polynomials, which means that their domain is negative infinity to infinity unless there's a denominator present. No questions. Who thinks this seems really, really easy?
That means there's a catch.
I don't want to say that it is, because I like throw something out there.
You never know.
So far,
Yes.
So far, it's pretty good, right? Let's do another one just as a practice.
yeah.
So now let's assume that f of x is equal to x squared plus 2, and g of x is equal to x minus 6. We're going to do the composition both ways. I'm going to do f of g first. Whenever you see an open circle that looks like an O, that means we're doing composition, not multiplication. Okay, you should know the difference between an open circle and a closed circle. If you're writing a problem like this, make sure you're very specific about whether it's an open circle or a closed circle because they mean different things here. So we're doing f of g, which means which one is my outside function? Everybody, which one is my outside function? F, because it is the one farthest from my variable x. Which one is my inside function then? G, make sure you know the difference. In alternate notation, which is how I always like to write them, it makes it a little bit easier to think about and comprehend. So then because G is the inside function, we're going to take G and plug it in for the variables in F. Which means my composition becomes x minus 6 squared plus 2. Correct? How would I simplify that out? So that would become x squared minus 36, right? No. Okay, so this is the same as having x minus 6 times x minus 6, which means I'm going to have to FOIL it because I have a binomial times a binomial. If it was a singular x in there or a singular 6 in there with no addition or subtraction, then I could have just squared it. But since it's not, I'm squaring that entire parentheses, which indicates multiplication. So I'm going to color code the FOIL just so you guys can kind of remember how to do it. So we're going to have x times x is x squared. X times a negative 6 is a negative 6x. Negative 6 times x is a negative 6x. And negative 6 times a negative 6 is a positive 36. And then I still have my plus 2 at the end. I expect this in simplified form, so I'm going to combine like terms. which leaves me with x squared minus 12x plus 38. Questions, concerns, or issues there? Now do the reverse order. I would now like to do g of f of x, or I don't know how you would even say that, gof. On your own, please do that one, and we will come together and check it. Still using that same f and g. Show of hands, how many of you got x squared minus 4? Good. Those of you who didn't, do we identify where the mistake happened? Okay. Is anybody confused by how we did this? We're good? Let's do another one. I know you're super duper loving this.
Is there any steps after doing this?
Yes, give me a second. We're just not there yet. Here's another example. What is different about this example compared to the other one? It's m instead of x. Does that change my process at all? No. I can use any variable I want. Just like the fact that I don't have to use f and g for my function names. I could use h or d or j or k or p or whatever I want to use. G and f are just our most common, and x is our typical variable letter. This can always change and it still follows the same process. So as an individual practice, please find both of these compositions. Key in. What did we get for g of f of m? So the first one. Yeah, got.
3m plus 8.
So he got 3m plus 8. Show of hands who else got 3m plus 8. That is entirely correct. Is anybody confused by how he got that? Delilah, what did you get for f of g of m? She got 3m minus 24. Show of hands who got that. That is also entirely correct. Does anybody have any issues with either of these? Are we okay? So what if I asked you to do something a little bit different? For example, what if I asked you to find f of f? Somebody who's confident, tell me what you think. Okay, which one's the inside function? Which one's the outside function? So we're literally taking f and plugging it into itself wherever there's a variable present. So if I were to write this one out in the other notation, it would be f of m. So I'm going to take f of m, which is negative 3m, and I'm going to plug that in where there's an m present. So this becomes negative 3 times negative 3m, which comes out to be 9m. It is also possible to have the composition of more than two functions. If that is the case, we always work from the inside out. So for example, I'm not going to give you actual functions because this is not on your homework, but it is a question that we can definitely work through. So let's say I have three functions. I have f of x, I have g of x, and I have h of x. So let's say in theory, I wanted to do g f of h of x. This means that I would plug h into f, then I would take whatever that f is and plug it in to g. So in the alternate notation, this would be g of f of h of x. And we would always start on the very, very inside. So we would do the h of x into f first, and then take this entire thing and plug it in to g. Again, this is not on your homework. Right now, you could kind of think about this as a theoretical composition. Does that kind of make sense, though? So we're not confined to just doing inception with two functions. We could have 100 if we really, really wanted to. I wouldn't want to do that problem, and I'd never give that problem to you, but it is theoretically possible. Questions, concerns, or issues so far? We are almost done. So let's say that when I do these compositions, I don't want to leave a variable in there. Instead, I want to solve at a specific value. It's going to work very, very similar to how we did it yesterday when we had specific values to plug in. So for example, let's say that I have two functions. We're going to go f of x again and g of x. We'll say f of x is 5x and g of x is negative 2x plus 1. And I would like to do the composition g of h of 3. Oh my gosh. G of f, yeah, thank you. Rewriting this in the other notation because it makes it a little bit more apparent how we'll be working through it. This becomes g of f of 3. So what is my very inside function here? Say it louder. It's f of 3, right? Because that's what's inside that set of parentheses. Which means I first have to know what f solved at 3 is before I can plug that into my outside function g. So I'm going to take 3 and I'm going to substitute it in for the variable in f, and I'm going to get a number. Then I'm going to take that number, and that's what I'm going to plug in for the variable in g. So we're going to find f of 3 first. So in this specific example, my f function is 5x. Which means f of 3 is 5 times 3, which equals what? So now I'm gonna take this 15 and I'm gonna plug it into my g function. So then g of 15 becomes negative 2 times 15 plus 1. Okay, so what did we come up with? Negative 29. Negative 2 times 15 is negative 30 plus 1 is negative 29. So you could say that g of f of 3 is negative 29.
Is that how you want us to write it?
Yeah, I like that a little bit better.
Do you want us to write it like that over the G of F?
Either you could this one equals negative 29 or this one equals negative 29. They both say the same thing, just in a different notation. So whichever one you like best. How bad was that? Anybody have any major issues with it? Okay, 1 to 5. How do we feel about it? 5, you could show somebody else how to do it. 1, you have absolutely no idea what's happening in your life. 1 to 5.
You get steps.
I know, I'm really short. It doesn't help. Okay, so I don't think we necessarily need a bunch more examples. I will do one more if that's what you guys want. If not, you're more than welcome to work on your homework. So show of hands, does anybody want or need another example? Okay, there are plenty more to look at in the notes if you do. If not, your homework, obviously, you should have already looked at it on Canvas. You should have plenty of time to finish it up today. Those of you online, you're more than welcome to get off if you are not having any questions for me. If you haven't finished the homework, you should work on that right now. And I will be on this Google call until the end of class if you have any questions.
And then look at the other, another long